Dear students, welcome to my new channel. In today's lecture, we'll learn thin layer chromatography under the course of pharmaceutical analysis. Let's start. So chromatography is an important biophysical technique that enables the separation, identification, purification, qualification, quantification, isolation of the components of a mixture for qualitative and quantitative analysis. In this physical method of separation, the components to be separated are distributed between two phases. One is stationary and another is mobile phase. Depending upon the stationary phase and mobile phase, they can be of different types. So TLC is a method for identifying substance and testing of the purity of compounds. TLC can be defined as the method of separation or identification of a mixture of components into individual components by using finely divided adsorbent solid or liquid spread over a plate and liquid as a mobile phase. TLC is a useful technique because it's relatively quick and requires small quantities of material. So why the name thin layer? Because in this technique we are using a thin plate, and within the thin plate we use the stationary phase as a thin layer. Okay, so that's why it is called thin layer chromatography, because a thin layer of the stationary phase like silica is used in this chromatographic technique. Separation in TLC involves distributing a mixture of two or more substances between stationary and mobile phase. The stationary phase is a thin layer of adsorbent coated on a plate, and the mobile phase is a developing liquid which travels up the stationary phase carrying the sample with it. So this is the actual function of the mobile phase. The mobile phase usually works as a developing liquid. Okay, in the column chromatography or gel filtration chromatography, we have already seen that mobile phase is actually used to just travel up the stationary phase, and they just take up the sample or the analytes. Okay, components of a sample will separate on the stationary phase according to how much they absorb on the stationary phase versus how much they dissolve in the mobile phase. So we can see here, this is the thin layer plate, and this is also the stationary phase, and this is the whole TLC chamber which is has been saturated with the mobile phase. So mobile phase kept here, we have to apply the sample here, and after that we put the TLC plate here, and then we see that TLC plate whenever is setting up here, then the sample get upward. Why they are getting upward? Because mobile phase, due to its capillary action, is going upward from here to there. The mobile phase will go. Okay, so it will just take up the sample, and based on their retention factor, the sample will get separated. We can see here, so sample has been applied, then it has been kept in a chamber. Then first of all we put the sample here, then actually mobile phase is getting upward and the sample is getting separated. Okay, that means that you have three analytes or three samples, three compounds in that point. Okay, so the three components have been separated based on their retention factor. So why compound A has come in the upper region or has traveled very fast? Because compound A has low polarity. Okay, compound A has lower interaction with stationary phase than mobile phase. But in case of compound C, it travels lately. Why it travels lately, or it's very slow? Because it has interacted with our polar silica or the polar stationary phase. That's why solvent C has the highest polarity, and compound C has the highest polarity, and compound A has the lowest polarity. So we can easily understand from this TLC method that there are three compounds in that sample, and compound A has the least polarity, and compound C has the highest polarity, and compound B has the intermediate polarity. Okay, so you can easily understand a lot of things like identification and their separation and isolation, and also can learn about their polarity. So when TLC is used? TLC is used if the substances are non-volatile or of low volatility, because for volatile substance we usually use the GC, gas chromatography. The substances are strong polar or medium polarity, non-polar or ionic. The large number of samples must be analyzed simultaneously, cost effective and within a limited period of time. No source of electricity is available, because in SPLC, GFC or in column chromatography we'll see the need of electricity, but TLC doesn't require that. The substance in the material being analyzed cannot be detected by the method of liquid chromatography or GC or with a great difficulty. So let's see the principle of TLC. As we have already seen, the sample are just interacting with the layer of the stationary phase. Like other chromatographic technique, thin layer chromatography depends on the separation principle. The separation relies on the relative affinity of the compounds towards both the phase, that is stationary and mobile phase. Okay, now the compounds will decide itself that it will interact with the stationary phase or it will go with the mobile phase. You see, if the compound is polar, then it will interact with the polar silica, that is the stationary phase. And whenever it will interact with the polar silica, then it will take more time to go with the mobile phase or to be eluted. Okay, so that is how separation is being performed based on their polarity. The compounds in the mobile phase move over the surface of the stationary phase. The movement occurs in such a way that the compounds which have higher affinity to the stationary phase move slowly while the other compounds travel fast. Therefore, the separation of the mixture is attained. On completion of the separation process, the individual components from the mixture appear as spots at respective level on the plates. Their character and nature are identified by suitable detection techniques. So here is the overall scenario. So let's see the overall procedure for TLC. First of all, we have taken a chamber like beaker, then we have kept the mobile phase, then we have put the TLC paper. Okay, then we put our sample here in a location. Okay, but be aware that our sample location should be just upward to the liquid or the mobile phase, because if you put the sample here, then what will ultimately happen? The sample will get dissolved within the mobile phase. Okay, we have put the sample. After that, we run the analysis. You can see the mobile phase has gone faster, and this blue colored sample has gone with the mobile phase, and the red one has very interaction with the stationary phase and thus eluted lately. Okay, this is the practical aspect of TLC paper. And now let's study the components of TLC. So TLC is composed of, first of all, TLC plate, preferably ready-made with stationary phase. These are stable and chemically inert plates where a thin layer of stationary phase is applied on its whole surface layer. The stationary phase on the plates is of uniform thickness and is in a fine particle size. So TLC chamber, this is used for the development of TLC plate. The chamber maintains a uniform environment inside the proper development of spot. It also prevents the evaporation of solvent and keep the process dust free. So before conducting the TLC, we need to saturate the chamber with the solvent. Okay. Then the mobile phase. This comprises of a solvent or solvent mixture. The mobile phase used should be particulate free and of highest purity for proper development of TLC spots. The solvents recommended are chemically inert with the sample stationary phase. A filter paper. This is moistened in a mobile phase to be placed inside the chamber. Then the overall experimentation, as we have already discussed, has been shown here. Now we'll learn step by step. First of all, preparing the chamber. To a jar with a tight fitting lid, add enough of the appropriate developing liquid so that it is 0.5 to 1 centimeter deep in the bottom of the jar. Close the jar tightly and let it stand for about 30 minutes so that the atmosphere in the jar becomes saturated with solvent. Then preparing the plate for development. With a pencil, etch two small notches into the adsorbent about 2 cm above from the plate. The notches should be on the edge of the plate and each notch should be the same distance up from the bottom of the plate. Okay, we have already shown. Then the notches must be further from the bottom of the plate than the depth of the solvent. Okay, otherwise what will ultimately happen? The notch would get dissolved with the solvent. So we should keep the notches just uh, upward to the solvent level. Using a drawn out capillary tube, spot the sample on the plate so that they line up with the notches you etch. Then developing the plates. After preparing the development chamber and spotting the sample, the plates are ready for development. Be careful to handle the plates only by their edges and try to leave the development chamber uncovered for as little time as possible. When the plates are removed from the chamber, quickly trace the solvent front with a pencil. Identifying the spot. If the spot can be seen, outline them with a pencil. If no spots are obvious, the most common visualization technique is to hold the plates under a UV lamp. Many organic compounds can be seen using this technique, and many commercially made plates often contain a substance which aids in the visualization of compounds. So these reagents are usually used for these compounds. And finally, interpreting the data. The RF value for each spot should be calculated. It is characteristics of any given compound on the same stationary phase using the same mobile phase for development of the plate. So we'll see the RF value. The more travel distance by the sample, the more would be its RF value. Hence, known RF value can be compared to the dose of unknown substance to aid in their identification. So you can see here, distance traveled by the substance divided by distance traveled by the solvent is known as RF value. So this is having the high RF value, this is having the low RF value. Okay, this is the basic theory. So RF value often depend on the temperature and solvent used in the TLC experiment. The most effective way to identify compound is to spot known substance authentic next to unknown substance on the same plate. In addition, the purity of a sample may be estimated from the chromatogram. An impure sample will often develop as 2 or more spots, while a pure sample will show only 1 spot. In principle, the components will differ in solubility and in strength of their adsorption to the adsorbent, and some components will be carried further up the plate than others. When the solvent has reached the top of the plate is removed from the developing chamber, dried, and separated components of the mixture are visualized. If the compounds are colored, visualization in the straightforward. Usually the compounds are not colored, so UV lamp is used for visualization of the plate. Basically, we use UV lamp whenever visualization is not uh, confirmed. But if visualization is takes place, then we don't usually use UV lamp. So let's see the application. It's a qualitative testing. Okay, so keep in mind that like other chromatography, like column chromatography or gel filtration chromatography or SPLC, we cannot quantify drug by the sample. So it is a qualitative testing useful in biochemical analysis and separation and isolation. Okay, like these are the qualitative tests: separation, purification, isolation, identification. Okay, can be used to identify natural products. Okay, like glycoside waxes. Then separating multi-component pharmaceutical formulation. Then used for the purification. Then used in the food cosmetic industry and separate identify color, sweetening agent, and preservative. So there are some disadvantages also because it is not so much efficient as like other chromatography like SPLC, GFC, okay, or chromatography. So they do not have longer stationary phase. Okay, when compared to other technique, the result generated from length of the separation is limited. Okay, difficult to reproduce. Moreover, as TLC plate is very open, then humidity and temperature can also affect the system. Then it is only a qualitative test. Okay. Moreover, detection limit is high, and therefore, if you want to lower detection limit, you cannot use TLC. So here, differences between paper chromatography and TLC has been shown. by analyzing this or by understanding, by reading this difference, you can easily see that TLC is much more efficient than paper chromatography, because at one time we used paper as a stationary phase when thin layer was absent. Then the main advantage is that paper is easily available, but the main problem is that this is not stable one. Okay, separation is less sharp. Okay, more time consuming and less sensitive. These are the overall problem of paper chromatography, but TLC is much more sensitive than paper chromatography. Okay, so these are the overall reason, uh, overall comparison between this, and at present we use TLC preferably other than paper chromatography. So these are all from TLC. If you have any confusion, please inform me in the comment section. Thank you.